In this demo, I'm going to show how we can work with a version of the iGEM dataset that is going to be converted into SPL and deposited within the SynBioHub repository. In particular, I'll be describing both the web interface as well as how this data can be accessed computationally via the software tool Sfull Designer. In this demo, I'm going to be illustrating the functionality using this design of a POPs receiver. In this design, we can go to SynBioHub to see it in its SPL format by going to Parts Tools and selecting SPL format. This brings up the SynBioHub page describing this design. If you click on the source link, it'll take you back to the parts registry page, which will show you more information as shown in the parts registry page. So let's go back to SynBioHub again. If we scroll down on the page, we can see a description of the part, as well as a visualization of the part. If you hover over each element in the visualization, it'll show you more information, such as this is a promoter that's located at positions 1 through 54 on the DNA sequence. This is a hierarchical part, and what I mean by that is that the terminator is actually a double terminator that is shown pictorially down below. You can also click on the terminator, or any of the parts, and take yourself to the page describing that individual part. So this is the page describing this double terminator. Let's now scroll back up to the top and look at some more of the fields at the top of the page. On the top of the page, we have additional information like who created the part, when it was created and last modified, short description of the part, its part status, which you can click on this link and it'll tell you what that means. This describes the part status box. This part was released HQ 2013. If you click on the search next to it, it'll find all other parts that were released in the HQ 2013 release. There are 1,930 such parts. Similarly, for all the other features described down below, you can also click on them to get a definition and click on the searches to get parts that match that type specified. When we get down to the bottom, we show the role for this part is engineered region. If you click on that, it'll take you to the description of what engineered region means. It's a term from the sequence ontology database of terms. Next, let's click on the sequence, and this takes us to a sequence page. On the sequence page, we can see the DNA sequence for the part, we can do blast searches on this sequence, and we can download the FASTA file describing this sequence. The last category are the collections that this part resides in. It is in the iGEM parts registry collection, the function cell signaling collection, and the classic signaling receiver collection. Let's take a look at the cell signaling collection. This brings up the collections page. On the collections page, it lists all the parts that are also in this collection, as well as sub-collections of this collection. And you can click on these, such as the LASR collection, which will show you the parts which are in the function cell signaling LASR collection. The last part of this page are the buttons shown on the right-hand side. You can download the SPL file, or we can download a GenBank version of this file. We can download an image, which you could use in publications or presentations for this design. We can then select Find Uses, and this will find all uses of this part, of which there are 94. We go look at one of these uses. This particular part has a bookmark icon to indicate that it's a favorite part, and star icon meaning that there's been good experience with this part. If we scroll down further, we can see how this part is designed. It includes this F2620 part, as well as additional ribosome binding sites, coding sequences, and terminators to complete the part. Let's go back to the original page, and the last button is Find Twins. These are parts that have the exact same DNA sequence as this part. When you hover over this, it says this is a dominant twin, and that's also indicated in green. There are two other parts that have the exact same DNA sequence, such as these two that are listed here. Okay, so now the next thing we'd like to do is to show you how you can build new parts using a software tool called Sfull Designer. So we go into Sfull Designer, and I'm going to build a design using the F2620 POPs receiver. So first I'm going to instantiate that receiver by clicking on the general part icon. Select Import Registry Part, and is now fetching all parts that have the role engineered region. And I'm going to enter in the part that I'm looking for and select that part and add that part to the design. Now if you select that part and focus in, you can see the substructure of the part. Indeed, if you focus in on the terminator, you can see its full substructure. So now I'm going to add to this POPs receiver a reporter. For that I need a ribosome binding site, a coding sequence, and a terminator, but I haven't decided which ones yet. So I'm just adding in abstract parts. I'm now going to give some more information about this design. So I click on the pencil, give it an ID, a new unique ID, a new name describing the part, and a new description. And save that information. You can also see the DNA sequence had gotten pulled in for this part. Okay, so now at this point I've decided that I want to save what I'm doing and come back to it later, and I want to do it up on the SynBioHub. I click on the cloud and I select synbiohub.org as where I want to upload the part. Press OK. I already have a user account in my name. I need to add in my password and select Upload. It's now been uploaded successfully. So let's go back and check that. So I click on Login, brings up the login page, and I select my login name and password. And then I click on Manage Submissions, and I can see that in my private repository I have a new part called My Receiver. And when I click on that, it gives me all the parts and sequences that I've just uploaded. If I click on My Receiver, then I can see indeed the part that with the abstract design has been successfully uploaded. So now I want to come back to my design and actually give it specific parts to use. So I'll go back to Sfull Designer, select on the ribosome binding site, click on the magnifying glass to get my parts, pick a part to add in, coding sequence, search for coding sequences. In this case, I want a GFP coding sequence. This one will be just fine. And then I'm going to add a terminator, and I'll add this terminator to the design. So now I've completed my design and I want to save the result I have. So I click on Upload, search for synbiohub.org, press OK, enter my password, and this time I want to select Overwrite because I want to replace it with what was there before. I can upload to update my design. My upload was successful. And if I come back here and I click on Manage Submissions, come back to my design, select My Receiver, and you can see that the new design has been updated with the specific parts that I wanted. Okay, so at this point, the last thing I want to show is the Advanced Search feature capability. So I'm going to click on Search and select Advanced Search. So here you can select various features like who created the part, when it was created, or just simply do a search of descriptions. What I'm going to do is I'm going to search for all promoters, which are released HQ 2013, are in stock, are available, and work. And in particular, I would like to find promoters which are positively regulated. So I'm looking for the positive regulation collection and perform a search. And I find that there are 8 such parts that meet all of these criteria. That concludes my demo.